Have you ever wondered what would happen if you crossed the final boundary of reality and never came back? Not in a poetic sense, not as a metaphor, but physically. What if you stepped into a place where time no longer behaves like time, where space collapses into itself, and where every law you have ever trusted quietly breaks down? Somewhere in the universe right now, there are regions so extreme that even light cannot escape them, not because light is weak, but because reality itself is warped beyond recognition. These places are black holes, and the most disturbing truth is not that they exist, but that they obey the same physics as everything else. A black hole is not a cosmic monster roaming the universe hunting stars. It does not suck everything around it like a vacuum cleaner. In fact, from far away it behaves like any other massive object. A star could orbit it peacefully for billions of years and never fall in. The danger begins only when you get too close, and once you cross a certain invisible boundary, there is no warning, no alarm, no sudden explosion. Nothing dramatic happens in that moment, and that is what makes it terrifying. This boundary is called the event horizon. It is the point where escape becomes impossible, not because something blocks your path, but because all possible paths now lead inward, forward, backward, sideways. Even the future itself points only one way inside this boundary. Space and time exchange roles. What we experience as movement through space becomes movement through time. Falling toward the center is no longer a choice, it is as inevitable as tomorrow. From the outside, an observer would see something deeply unsettling as you approach the event horizon. Your movement slows down, your image freezes, your signals stretch and fade. You never seem to cross the line at all. You simply linger there, suspended, forever, slowly dissolving into darkness. But from your own perspective, nothing like that happens. You fall normally, your heart beats normally, time feels normal. You cross the horizon without noticing anything special, and that contradiction is not a trick. It is real. Both perspectives are correct at the same time. This is where black holes stop being just objects in space and become mirrors for the limits of human understanding. They expose a fracture between how reality is experienced and how it is described. They force us to confront a universe that does not care about intuition, comfort, or common sense. Everything we believe about causality, identity, and continuity begins to blur, and here is the most unsettling part. Black holes are not rare. At the center of nearly every galaxy, including our own, there is a supermassive black hole quietly holding everything together, the Milky Way. If a black hole could speak, it would not threaten, it would invite, it would not roar, it would whisper, because the most terrifying thing about a black hole is not that it destroys, but that it obeys the same rules as everything else. Only gravity, only equations, only inevitability. Long before a star collapses into a black hole, it lives a perfectly ordinary cosmic life, burning fuel, balancing outward pressure with inward gravity. But when the fuel runs out, gravity finally wins, and the core collapses faster than the speed at which information can escape. Space itself caves inward, and something unprecedented is born. A region where the known laws of physics no longer fully apply. At the center is the singularity, a point of infinite density where mass is crushed into zero volume. This is not just heavy matter, this is matter pushed beyond meaning. Around it forms the event horizon, a boundary, not of matter, but of fate. Cross it, and there is no return, not because something blocks you, but because all possible paths forward lead inward. Even light cannot escape, because space itself is flowing faster than light can move. Outward, imagine standing on a river where the current becomes stronger and stronger until even the fastest swimmer cannot move. Upstream, that is a black hole from the outside. It looks calm and visible. Even yet inside, time and space swap roles. What we call future points inward toward the singularity. There is no turning around, because turning around would require going backward in time. This is why black holes are not cosmic vacuum cleaners. They do not hunt, they wait. And that waiting reveals something deeply unsettling. The universe allows places where the future ends, where cause and effect still function but lead only one way. In these regions, reality does not explode, it simplifies. Everything becomes direction, and that direction is down, not down in space, but down in possibility. What makes this more disturbing is that black holes are not rare. They are everywhere. At the center of most galaxies, including our own, lurks a supermassive black hole millions or billions of times heavier than the Sun. The Milky Way itself orbits Sagittarius A, not because it is violent, but because it is patient. Our galaxy is shaped by an object that emits no light and cannot be seen directly. only its influence reveals it. This mirrors something. Psychological humans are often most affected not by what screams for attention, but by what silently bends the structure around it. Black holes teach us that the universe does not need intention to be lethal. It only needs consistency. Gravity does not hate you, time does. Not judge you, they simply do what they do. And if you fall into their logic deeply enough, there is no escape. This is not cosmic evil, it is something colder, something more honest. And perhaps that is why black holes unsettle us so deeply. What happens to time when you approach a black hole is not a metaphor, not science fiction, and not philosophy. It is physics, and it is terrifyingly real. Far away from a black hole, time behaves normally. Seconds pass, minutes stack neatly on top of one another. Cause follows effect. But as you move closer, something fundamental breaks. Time itself begins to slow, not for you, but relative to the rest of the universe. This is not an illusion. It is not perception. It is baked into the structure of space-time itself. Einstein predicted it. Experiments confirmed it. And black holes push this effect to its absolute extreme. From the perspective of a distant observer, you would appear to slow down as you fall toward the black hole. Your movements stretching, your heartbeat dragging, your entire existence decelerating. You would never quite cross the event horizon. You would freeze, dim and fade, locked forever in the final moment before disappearance. But from your own perspective, nothing unusual would happen at first. Your watch would tick normally. Your thoughts would flow uninterrupted. You would cross the event horizon in finite time, unaware that the rest of the universe has effectively raced billions of years into the future without you. This is where black holes stop being objects and become time machines. They do not send you backward. They send everyone else forward. A journey toward a black hole is a one-way ticket into the future of the universe. If you could somehow survive the tidal forces, you could emerge into a cosmos long dead. Stars burned out, galaxies dispersed, all while you experienced only minutes or hours. Time dilation near a black hole is so extreme that the future piles up outside, while your present crawls forward. And deeper still, beyond the event horizon, time and space swap roles. Forward no longer means forward. Movement is no longer a choice. Just as you cannot stop moving forward in time right now, inside a black hole, you cannot stop moving toward the singularity. It is not a place you travel to. It is a moment you are forced into. Every possible future path points inward. This is why escape is impossible, not because of force, but because of causality. To escape would require moving backward in time. Black holes do not merely trap matter, they trap futures. They rewrite the rules that define what later even means. And this leads to one of the most disturbing realizations in modern physics. If time can slow, stretch, twist, and collapse, then it is not fundamental. It is emergent, a property, not a law. Near a black hole, time behaves less like a river and more like a fragile structure under stress, bending until it fractures. And if time can break there, the question becomes unavoidable. What else that we take for granted is only temporary? Crossing the event horizon is not dramatic in the way movies suggest. There is no wall, no flash of light, no sudden impact. If the black hole is massive enough, you would pass the boundary without feeling anything at all. No alarm would sound, no force would push you back. And that is precisely what makes it terrifying. The event horizon is not a physical surface. It is a limit of information. The last place where cause and effect still make sense to the outside universe. Once you cross it, every signal you send, every photon you emit, every scream you could imagine is trapped forever. Not because it is blocked, but because the geometry of space-time no longer allows paths that lead outward. From that moment on, your future is sealed. Inside the horizon, space itself flows inward faster than light can travel outward. You are not falling through space toward the center. Space is falling with you. This is where our intuition completely fails. The singularity is not down there like the bottom of a pit. It is in your future, as unavoidable as tomorrow. No amount of thrust, no clever maneuver, no technology imaginable within known physics can change that trajectory. And as you move deeper, the environment becomes increasingly hostile. Tidal forces begin to stretch and compress you, pulling your body apart in a process physicists grimly call spaghettification. If the black hole is small, this happens quickly and violently. If it is supermassive, you might survive long enough to witness something far stranger. Inside the horizon, distances lose their familiar meaning. Directions stop behaving intuitively. Forward is no longer a direction. You choose but a destination you are dragged toward. And near the singularity, our equations collapse entirely. General relativity predicts infinite density, infinite curvature, infinite breakdown. These infinities are not real things. They are warning signs that our understanding has failed. Physics simply stops working there, which raises a disturbing possibility. The singularity may not be a point at all. It may be a boundary between descriptions, where space-time dissolves into something deeper we do not yet understand. Some theories suggest it could be a region where time ends. Others propose it connects to another universe, or another region of our own, hidden behind an irreversible veil. But no matter which idea is correct, one fact remains. Whatever happens beyond the event horizon is fundamentally disconnected from us. Black holes are places where the universe hides its answers. They are not just destructive objects. They are censorship mechanisms built into reality itself. Time behaves strangely near a black hole, but beyond the event horizon it ceases to behave at all in any way we can easily describe. Outside, we talk about time slowing down due to gravity, clocks ticking more slowly near massive objects. But inside the horizon, time is no longer just slowed. It is redirected. In normal life, time flows forward and space gives you freedom of movement. Inside a black hole, these roles reverse. Time becomes a direction, not a duration. Just as you cannot choose to stop moving forward in time outside a black hole, you cannot choose to stop moving toward the singularity once you are inside. It is not a place you fall into. It is a moment you must reach. This inversion shatters every instinct you have about survival. You cannot wait. You cannot turn back. Even standing still becomes impossible because still no longer exists. Every second carries you closer to the end state of space-time itself. From the outside, an observer never sees you cross the horizon. Your image freezes, reddens, fades. But for you, nothing special happens at the boundary. You continue inward, carrying your own clock, your own memories, your own sense of now. This creates one of the deepest paradoxes in physics. Two observers, both correct, witnessing incompatible realities. One sees you frozen forever. The other lives on, moving toward destruction. Both descriptions are true within their frames. Reality itself fractures along the horizon. This is not just philosophical discomfort. It points to something fundamental. Time is not absolute. It is not universal. It is local, fragile, shaped by gravity and motion. And black holes reveal this mercilessly. Near the singularity, time may not merely slow or speed up. Some theories suggest it ends entirely. Others suggest it loops, branches, or dissolves into quantum uncertainty. We do not know. Our equations give nonsense results, infinities stacked on infinities, as if the universe is screaming that we are asking the wrong questions. Perhaps time is emergent, a surface phenomenon like temperature, meaningless at the deepest level. Or perhaps black holes are places where causality itself is restructured, where before and after lose meaning. If so, then falling into a black hole is not just dying. It is exiting the story as we understand it. The universe keeps going. You do not, and yet the information you carried may still matter, which leads to the most unsettling question of all. If nothing escapes a black hole, what happens to the information of everything that falls in? For decades, black holes were thought to be the ultimate destroyers. Anything that crossed the event horizon was gone forever, erased from the universe without a trace. But in physics, destruction is a dangerous word. According to quantum mechanics, information cannot be destroyed. Every particle carries data about its state, its history, its relationships. If black holes truly erase information, then one of the deepest laws of reality is broken. This conflict is known as the black hole information paradox, and it sits at the fault line between general relativity and quantum physics. In the 1970s, Stephen Hawking shocked the scientific world by showing that black holes are not completely black. They emit radiation, now called Hawking radiation, caused by quantum fluctuations near the event horizon. Over unimaginably long timescales, this radiation causes black holes to evaporate. If a black hole can disappear, what happens to the information that fell inside it? Hawking initially argued that the information was lost forever, smeared into randomness. This conclusion horrified physicists because it meant the universe could forget. Over time, Hawking changed his position. New theories suggested that information is not destroyed but encoded in subtle correlations within Hawking radiation. The event horizon may act not as a one-way trap, but as a kind of cosmic hard drive, storing information on its surface in an incredibly compressed form. This idea led to the holographic principle, which proposes that all the information inside a volume of space can be described by data on its boundary. In this view, the universe itself may be a hologram, with reality encoded on distant surfaces. Black holes become laboratories for testing the deepest structure of existence. But the paradox is not fully resolved. Some models suggest that information escapes slowly, Others propose that it is preserved in hidden dimensions. More radical ideas imply that space-time itself must be redefined. What is clear is this: black holes are not just astrophysical objects. They are pressure points in reality, places where our theories strain and sometimes break. They force us to ask whether the universe is fundamentally logical, or whether there are limits to what can be known. When we stare into a black hole, we are not just looking at gravity or matter. We are looking at the boundary of knowledge itself. As you fall toward a black hole, something strange happens to time. To an outside observer, you never actually cross the event horizon. Your image slows, reddens, and freezes, stretched into darkness as time itself appears to stop. But for you, the fall continues. Your clock ticks normally. Your thoughts follow one another. This contradiction is not an illusion. Both perspectives are true. Time near a black hole does not behave as a single universal flow. It fragments depending on where you stand. As gravity intensifies, tidal forces begin to dominate. These forces stretch objects in the direction of gravity and compress them sideways. This is what physicists grimly call spaghettification. Feet pulled harder than the head, atoms stretched into chains, molecules torn apart. Near a stellar mass black hole, this process would kill you long before reaching the horizon. But near a supermassive black hole, like the one at the center of our galaxy, tidal forces at the horizon are surprisingly gentle. You could cross without immediate destruction, unaware that you had passed the point of no return. Then comes the deeper descent. Inside, space-time is so warped that every possible future leads inward. You are no longer falling through space. You are moving toward the future in the direction of the singularity. This raises a disturbing question. What happens to consciousness in such a place? Does awareness persist as the body is torn apart? Some theories suggest that information, including the quantum state of your brain, is not destroyed, but smeared across the event horizon. Others argue that consciousness cannot survive once causal structure collapses. There is also the unsettling possibility that, from your perspective, everything happens in a finite time. You experience the end, no infinite fall, no endless darkness, just a final moment where time itself ceases to have meaning. Black holes force us to confront uncomfortable ideas. That time is not fundamental. That identity may be tied to space-time structure. That awareness could be fragile, dependent on the geometry of the universe. In studying black holes, we are not only studying distant cosmic objects, we are testing the boundaries of what it means to exist in a universe where reality itself can fold, stretch, and erase the future. The black hole does not just consume matter, it consumes certainty. At the heart of every black hole lies a contradiction so severe that it threatens the foundations of modern physics. It is called the black hole information paradox, and it asks a question that sounds simple but is anything but. Does the universe forget? According to quantum mechanics, information can never be destroyed. The exact state of every particle, every interaction, every thought encoded in matter should always be preserved. But according to classical interpretations of black holes, anything that crosses the event horizon is gone forever, erased from reality. If black holes truly destroy information, then quantum mechanics is wrong. If information survives, then our understanding of black holes is incomplete. Both cannot be true. For decades, this paradox haunted physicists. Stephen Hawking initially argued that information was lost, sending shockwaves through theoretical physics. Later, he reversed his position, suggesting that information might be encoded on the event horizon itself, subtly leaking out through Hawking radiation. This led to a radical idea, that black holes are not empty objects but complex quantum systems, that the surface of a black hole may store information like a cosmic hard drive. This idea evolved into the holographic principle, the notion that all the information contained within a volume of space can be represented on its boundary. If true, then our entire universe may be a kind of hologram, where three-dimensional reality emerges from information encoded on a distant surface. Black holes would then be extreme. Laboratories revealing how reality itself is constructed. More recently, theories involving quantum entanglement and space-time geometry suggest something even stranger, that space-time itself may be woven from information. That gravity is not a fundamental force, but an emergent effect arising from the structure of quantum data. In this view, black holes do not destroy reality. They compress it, transform it, and perhaps recycle it. But there is no consensus. Some models predict that information escapes slowly over unimaginable timescales. Others suggest remnants. Others propose that our understanding of causality breaks down entirely. What remains certain is this: black holes expose the limits of human knowledge. They sit at the intersection of gravity, quantum mechanics, time, and existence. They force us to accept that the universe may not be intuitive, comforting, or complete. And perhaps the most unsettling conclusion is this: the black hole is not an anomaly. It is a feature, a natural outcome of the laws that govern everything, which means the universe is capable of producing regions where meaning, time, and certainty collapse. Studying black holes is not about distant stars. It is about understanding whether reality itself is stable, or whether beneath what we see lies something far stranger. In the end, the black hole does not give us answers. It gives us better questions.